the history we are taught often appears as a smooth, logical flow, a complete, explained, and neatly arranged. It feels as if everything has already been understood, categorized, and settled. But if you slow down for a moment, if you linger between the dates and listen carefully to the silences, something else begins to emerge. You start to notice questions that were never fully answered, structures that seem to appear earlier than the technologies we officially attribute to their time, civilizations that vanish without leaving behind clear signs of decline or collapse, maps, numbers, and systems of knowledge that feel strangely out of place, as if they were thousands of years ahead of the era they supposedly belonged to. In this special episode of Bedtime History, we are not trying to overturn history, and we are not here to create conspiracy stories or dramatic claims. Instead, we invite you to gently explore some of the greatest ancient mysteries. Real stories documented by archaeology and historical research, yet often simplified, avoided, or quietly set aside. Not because they are false, but because they do not fit easily into the familiar picture of the past we have grown comfortable with. The goal is not to arrive at one final, absolute answer. It is to relearn how to ask questions that time itself has pushed into the background. And as the night grows quieter, perhaps history will begin to whisper. Not loudly, not urgently, but in a softer voice, inviting us to listen once again. If we turn back time to the late 19th century, when archaeology was still a young field, human history was often presented as a simple, linear progression: hunting, gathering, agriculture, and then civilization. But in the year 1896, at the site of Sacsayhuaman near Cusco in Peru, the massive stone walls of the Inca began to pose a difficult problem. Stone blocks weighing between 20 and more than 100 tons were cut and fitted together with such precision that not even a thin blade could slide between the joints, all without the use of mortar. What makes this even more striking is that the structure was completed before the year 1537, when the Spanish first recorded its existence, at a time when Inca metal technology was limited to copper and bronze. There were no wheels, no large draft animals, no iron tools, and yet the level of precision surpassed that of many European structures from the same period. The question then is not whether the Inca were capable of building such works, but how they did so within the framework of knowledge and tools officially attributed to them. Conventional explanations often stop at collective labor and long construction timelines, but these ideas do not fully explain the complex polygonal stone-cutting techniques or the exceptional earthquake resistance these walls have demonstrated for more than 4 centuries. A similar problem appears much earlier, around the year 2500 before the Common Era, on the Giza Plateau in Egypt. The Great Pyramid of Khufu, completed around 2560 before the Common Era, is made up of more than 2.3 million stone blocks, each weighing an average of 2.5 tons. What continues to puzzle modern researchers is not only the scale of the project, but its astronomical precision. The 4 sides of the pyramid align almost perfectly with the 4 cardinal directions of the Earth, with a deviation of less than 1/10 of a degree. To this day, there is no clear consensus on the methods ancient Egyptians used to achieve this level of accuracy, especially in the absence of optical instruments. These mysteries do not exist outside the historical record. They are taught, documented and acknowledged, yet they are often presented as marvels, a word that quietly avoids deeper analysis of the true technological and intellectual capacities of ancient civilizations. When we label something a marvel, we accept it as an exception rather than as evidence of a sophisticated system of knowledge that may have been lost. Around the year 1872, Heinrich Schliemann excavated the city of Troy in present-day Turkey, confirming that a city described in the Iliad had truly existed. But Troy was not just a single city. Beneath the surface lay 9 layers of settlement stacked atop one another, spanning from around 3000 before the Common Era to the Roman period. Each layer revealed cycles of development, collapse, and rebuilding, suggesting that human history does not move forward in a straight line, but unfolds in recurring patterns. Yet this cyclical model rarely appears in popular historical narratives, which tend to favor simpler, linear timelines. These are massive stone structures, buried cities, and unexplained techniques are not evidence of the mystical or the supernatural. They are signs of gaps in modern knowledge, points where our understanding has not yet caught up with the traces left behind by the past. And from these gaps, a deeper question begins to take shape. How human beings lived, remembered, and passed on their past long before writing ever existed. According to the mainstream view, writing emerged around the year 3200 before the Common Era in Mesopotamia, with the cuneiform clay tablets of the Sumerians. From that point on, history is said to begin. But this division also pushes tens of thousands of years before it into a vague shadow, compressed into a single, shallow label: prehistory. Around the year 1994, in the Chauvet Cave in southern France, archaeologists discovered animal paintings dated to approximately 30,000 to 32,000 years before the Common Era. These images were not spontaneous or crude. They display movement, perspective, and proportions so precise that they reveal a high level of observation and abstract thinking. This directly challenges the long-held assumption that sophisticated art only appears after societies become settled and socially complex. If humans already possessed advanced symbolic thinking during the Paleolithic period, the next question becomes how their knowledge was passed down. In many non-literate cultures, collective memory takes the place of written records. Anthropological research in the 20th century, especially the work of Milman Parry and Albert Lord in the 1930s, showed that oral societies are capable of preserving and transmitting enormous amounts of information through rhythm, imagery, and deliberate repetition. Epic stories were not just entertainment. They functioned as archives of knowledge. This perspective changes how we view ancient myths. When the ancient Greeks spoke of a heroic age before the Trojan War, or when Indian traditions described cycles of destruction and rebirth of the world, these stories were often dismissed as pure symbolism. But within the context of oral transmission lasting thousands of years, such narratives may have preserved memories of real events, altered over time, yet not entirely fictional. A striking example comes from Australia. Research published from the year 2015 onward shows that some Aboriginal oral traditions accurately describe sea level changes that occurred at the end of the last ice age, around 10,000 to 12,000 years before the Common Era. These stories were passed down verbally across hundreds of generations without written texts. If this is correct, then human memory may extend far beyond what written history usually acknowledges. By prioritizing writing, mainstream history unintentionally creates an artificial boundary between what is considered historical and non-historical. Societies that left no written records are often seen as lacking complex pasts, even though they may have possessed sophisticated systems of knowledge, simply encoded in different forms. When historians focus only on what was written down, they also overlook what was remembered, recited, and embedded in ritual. The long silence before the year 3200 before the Common Era was not an empty time. It represents lost chapters of human history, where memory replaced ink and stone, and where knowledge was preserved not only through stories, but through other intricate structures. And when oral memory shows that humans can preserve information across thousands of years, the knowledge encoded in numbers and in the sky raises an even deeper question. Did ancient civilizations understand the universe far earlier than the timelines accepted by modern history allow? One of the clearest traces of this question appeared at the beginning of the 20th century, when divers off the Greek island of Antikythera discovered a corroded mass of metal inside the wreck of a sunken Roman ship. It took many decades before scientists realized that this was not a decorative object or an ordinary tool, but a complex mechanical system of gears dating to around the year 100 before the Common Era. The Antikythera mechanism, as it later came to be known, consists of more than 30 bronze gears, crafted with a level of precision that would not appear again until European astronomical clocks of the 14th century. X-ray analysis conducted in the year 2005 revealed that the device could predict solar eclipses, lunar eclipses, the cycles of the moon, and even the 19-year Metonic cycle. This suggests that ancient Greek scholars were not only observing the sky, but translating astronomical laws into an advanced mechanical model. Yet the Antikythera mechanism is often presented as a brilliant exception rather than as evidence of a broader technological tradition. The more important question is this: if such a device existed around the year 100 before the Common Era, why have no other similar examples been found? One possibility is that devices made from valuable metals were melted down and reused during periods of crisis, war, and collapse. Another is that the knowledge required to build them existed only within small, specialized circles, never widely shared. Early astronomical understanding was not limited to the Mediterranean world. In Mesoamerica, the Maya developed the Tzolk'in and Harb calendars by at least the 3rd century before the Common Era, combining them into a 52-year cycle so precise that it deviates by only a few minutes per year. Their long count calendar begins on August 11th, 3114 before the Common Era in the modern calendar, a symbolic date that also demonstrates an ability to calculate deep into the distant past. Inscriptions at sites such as Copan and Palenque show that the Maya could predict astronomical events hundreds of years into the future. What is striking is that these civilizations possessed no telescopes and no modern measuring instruments. Their knowledge was built on careful observation sustained across generations, recorded through symbols, architecture, and ritual. When the Pyramid of El Castillo at Chichen Itza produces the image of a serpent of light descending its steps during the spring and autumn equinoxes, this is not a coincidence. The structure was completed around the year 1050 after the Common Era, and the precision of the phenomenon shows that architecture and astronomy were deliberately combined. Mainstream history often separates science and religion when interpreting the past. But for ancient civilizations, these two realms were inseparable. Astronomy was not only a way to understand the universe, but a tool for regulating agriculture, ritual life, and political authority. When such knowledge was lost through war, disease, or conquest, it left behind gaps that later generations struggled to fill with only a handful of surviving artifacts. The corroded gears resting on the seafloor, the numbers carved into Mesoamerican limestone, and the monuments aligned with the sky are not isolated fragments. Together they suggest that ancient knowledge once possessed a depth and internal coherence far greater than the simplified image we often accept. And when these traces are placed side by side, a larger question begins to take shape. If ancient people could measure time, track cosmic cycles, and encode information in architecture, then the way they understood and recorded the world itself may have been far more complex than we imagine. From this point onward, ancient maps open up an even more uncomfortable problem for mainstream history: how people in the past could describe the Earth with a level of accuracy that seems to exceed their known range of travel and technology. In the year 1513, after the Common Era, the Ottoman admiral Piri Reis completed a nautical map based on much older sources, as he himself noted in its annotations. When this map was rediscovered in the year 1929 at the Topkapi Palace in Istanbul, researchers realized that it depicted the west coast of Africa, South America, and the Atlantic Ocean with remarkable precision. The controversy does not lie in the appearance of South America, since the voyages of Columbus had already taken place by the year 1492. The real issue lies in the southern portion of the map, where some researchers argue that it shows the coastline of Antarctica free of ice. Modern geological surveys suggest that these regions were last free of thick ice around the year 4000 before the Common Era. If this interpretation is correct, then a deeper question follows. Where did Piri Reis's original source data come from, and who surveyed Antarctica long before the modern age? Even though this interpretation remains debated, the Piri Reis map is not an isolated case. The map drawn by Oronce Fine in the year 1531 after the Common Era also depicts a southern continent with detailed river systems, nearly 3 centuries before Antarctica was officially discovered in the year 1820. The history of cartography often explains such details as speculation or coincidence. Yet the repeated appearance of accurate geographic features across multiple maps, created by individuals who had no contact with one another, makes the idea of pure imagination increasingly difficult to sustain. At the heart of this issue lies the question of where knowledge originates. Medieval and Renaissance cartographers rarely explored the world themselves. Instead, they copied, revised, and compiled material from older sources, sometimes dating back thousands of years. When the originals were lost, burned, or dismissed as outdated, only later copies remained, making the original knowledge difficult to trace. Modern history, which relies heavily on surviving direct evidence, often struggles to account for these long chains of transmission. Maps are not merely tools for navigation. They reflect how people understand the world and their place within it. When a map displays accurate latitude and longitude without the use of precise timekeeping devices, it challenges the assumption that such measurements were only possible after the 18th century. Explaining this away as luck or individual genius may ease the discomfort, but it does not resolve the deeper issue, that this knowledge existed somewhere long before it became fragmented and lost. Ancient maps, therefore, are not proof of early global travel, but traces of a long-standing tradition of observation and record-keeping that accumulated information across generations. When these traditions collapsed, knowledge did not vanish overnight. It drifted, was copied incompletely, misunderstood, and eventually turned into the mysteries that puzzle later generations. And it is within this landscape of scattered fragments that an unexpected archaeological discovery can sometimes force history to pause and look back at itself, as happened at a site in southeastern Turkey where massive stone pillars were uncovered during ordinary agricultural work. The excavations that followed, led by archaeologist Klaus Schmidt, beginning in the year 1995, brought Göbekli Tepe fully into the light. The T-shaped stone pillars at Göbekli Tepe are intricately carved with animals and abstract symbols and are dated to roughly 9,600 to 8,200 before the Common Era. What unsettled researchers was not their age alone, but their context. According to the dominant historical model, humans at this time were still living primarily as hunter-gatherers, with no settled agriculture, no pottery, and no complex, stratified societies. Yet Göbekli Tepe required a large workforce, a high level of social organization, and a shared symbolic system strong enough to sustain construction across generations. The existence of Göbekli Tepe forced archaeologists to reverse a fundamental assumption. Rather than agriculture leading to religion and monumental architecture, it may have been shared ritual and belief that first drew people together, gradually pushing them to develop agriculture in order to sustain growing communities. If this is true, then the origins of complex society lie not in economics but in symbolic thought. This represents a profound shift in how civilization is understood, yet it is rarely emphasized in standard textbooks. Göbekli Tepe also does not stand alone. Nearby sites, such as Karahan Tepe, more extensively excavated from the year 2018 onward, reveal a network of ritual centers spread across northern Mesopotamia, sharing similar dates and symbolic styles. This suggests that toward the end of the Ice Age, highly organized communities already existed, linked through shared rituals and knowledge, even though they left behind no clear evidence of permanent housing or writing. Another question arises from the way Göbekli Tepe itself was buried. Around the year 8000 before the Common Era, the entire complex appears to have been deliberately filled in, rather than abandoned due to natural disaster. Burying a structure of this scale would have required coordinated collective effort, indicating a conscious decision, possibly driven by deep ritual or social meaning. Yet the purpose of this act remains unresolved. Mainstream history often struggles with sites like Göbekli Tepe because they do not fit comfortably into the familiar linear sequence of development. When a discovery forces the starting point of civilization to be rewritten, the usual response is to treat it as an exception rather than to revise the broader framework. But exceptions that repeat themselves again and again eventually stop being exceptions. These ancient stone pillars tell us nothing about kings or wars. They speak instead of gathering, of ritual, and of humanity's ability to create social order even before the rise of stable agricultural economies. When Göbekli Tepe pushes the beginning of civilization back by thousands of years, it also suggests that many deeper layers of history may still lie hidden beneath the ground, waiting to reopen questions we once believed were already settled. And to understand why those early chapters may have faded from humanity's shared memory, we must turn to the harsh environmental conditions that people of that time were forced to confront. Around the year 12,900 before the Common Era, the Earth experienced a major climatic shock that scientists call the Younger Dryas, a sudden return to colder conditions that lasted for more than 1,000 years, reversing the warming trend that followed the last ice age. Evidence of this event is preserved in Greenland ice cores, ocean sediments, and fossil pollen across multiple continents, revealing a rapidly changing world in which early human societies may have been scattered, disrupted, or forced to adapt in ways that later memory could no longer fully preserve. The Younger Dryas was not simply a drop in temperature. It brought widespread droughts, ecosystem collapse, and the extinction of many large animal species. For hunter-gatherer communities and emerging ritual centers, this may have been an existential shock. Beginning in the late 20th century, some researchers proposed that this period either destroyed or dispersed many early complex societies, leaving their traces faint and fragmented in the archaeological record. One of the most controversial hypotheses linked to the Younger Dryas is the possibility of a comet or meteor impact or a fragmented meteor airburst around the year 12,800 before the Common Era. Studies published from the year 2007 onward reported unusual concentrations of platinum, nanodiamonds, and carbon-rich soot layers at more than 20 sites across North America, Europe, and the Middle East. These markers point to a high-energy event capable of triggering massive wildfires and rapidly altering the global climate. This hypothesis remains debated, and it is not accepted by all scientific communities. What is striking, however, is how it intersects with ancient traditions. Many cultures, from Mesopotamia and India to the Americas, preserve stories of a great catastrophe in the distant past, often described as fire from the sky or a world-destroying flood. When such accounts are dismissed as pure myth, the potential connection between collective memory and geological events is quietly set aside. In North America, the Clovis culture, which existed from roughly 13,500 to 12,900 before the Common Era, disappears almost abruptly at the onset of the Younger Dryas. Their distinctive stone tools no longer appear in later geological layers. In their place are different, often simpler tool traditions. This disruption suggests that progress is not always inherited in a continuous line. A sufficiently large environmental shock can sever chains of knowledge transmission across generations. If early communities, such as those who built Göbekli Tepe, existed before the Younger Dryas, then abrupt climate change may help explain why these ritual centers were abandoned or deliberately buried. In times of instability, the closure of sacred sites or the ending of a social cycle may have carried ritual meaning rather than being a purely practical response to survival pressures. Even so, modern archaeology still lacks the data needed to directly link specific sites to this global climatic event. Mainstream history often portrays civilization as a steady upward trajectory, interrupted only by local setbacks. The Younger Dryas challenges this view, showing that the entire planet can experience shocks powerful enough to blur or reshape human history on a global scale. When early societies fractured, their knowledge did not vanish entirely. It may have survived in memory, ritual, and cultural fragments, later resurfacing in altered forms within younger civilizations. Past climate upheavals, therefore, cannot be treated as a passive backdrop. They function as quiet historical forces capable of breaking old orders, opening new migration corridors, and forcing humanity to reorganize how it lives. Yet for much of the 20th century, when history was reconstructed mainly from land-based evidence, a crucial chapter of the post-Ice Age world remained overlooked. As the ice melted, sea levels rose by more than 100 meters, submerging vast coastal regions that had once been familiar living spaces for prehistoric communities. This means that a significant portion of human history was not erased. It was simply hidden beneath the sea. It is precisely within this gap in understanding that discoveries off the coast of Gujarat, India, begin to take on a meaning far beyond a local context. Beneath the waters of the Gulf of Khambat, geometric structures stretching for several kilometers, arranged in patterns difficult to attribute to natural chance, suggest that these now submerged coastal regions may once have held very early centers of habitation. Dating from organic samples points to a timeline far deeper than the familiar historical framework, raising questions not about a single site, but about entire chapters of prehistory that may now lie silent beneath today's sea levels. These findings quickly became controversial. Some geologists argue that the structures are simply natural formations shaped by currents and sedimentation. Supporters of the submerged city hypothesis, however, point to the regular spacing and repeated right angles, features that are difficult to explain as purely natural. This debate highlights a broader issue. Underwater archaeology remains a relatively young field, limited by technology and extremely high costs, leaving many potential sites insufficiently explored. Another example appears in Japan. In the year 1986, diver Kihachiro Aratake discovered a massive underwater stone structure near Yonaguni Island. The formation includes large step terraces, broad flat surfaces, and sharp edges lying at a depth of about 25 meters. Some geologists consider it a naturally eroded rock formation, while other researchers note surfaces that appear deliberately cut or shaped. If Yonaguni stood above sea level before the year 10,000 before the Common Era, the possibility of human interaction with, and modification of, the structure cannot be entirely dismissed. The existence of such underwater sites forces us to reconsider what we mean by disappearance. When a civilization is submerged by rapidly rising sea levels after the Ice Age, its traces are not immediately destroyed but hidden from view. History, which relies heavily on what remains above ground, can easily overlook chapters that lie beneath saltwater. Migration studies show that modern humans have lived along coastlines since at least the year 60,000 before the Common Era. Coastal environments offered stable food sources, efficient routes of movement, and opportunities for exchange. If some of these communities developed into sizable population centers, it is understandable that they would vanish from the historical record once sea levels rose. But understandable disappearance does not mean they never existed. Mainstream history typically places the origins of urban life in Mesopotamia and the Nile Valley around the year 3500 before the Common Era. Yet if early coastal communities formed thousands of years earlier, then the story of urban development may have been far more diverse than commonly assumed. A lack of evidence does not necessarily equal evidence of absence. In this case, it may simply reflect the limits of where we have chosen, or been able, to look. Underwater discoveries therefore do more than expand the physical space of history. They quietly reshape the questions we ask. When we begin to see that ancient societies may have vanished not because they lacked organization, but because their environments were erased from the map, we are forced to set aside familiar assumptions about the primitive nature of the past. For if geography itself can conceal entire settlements, it is entirely possible that other traces of ancient knowledge have also been misunderstood, overlooked, or underestimated. From this point onward, attention no longer turns only toward the oceans, but gradually back toward the people who once lived in those spaces, how they observed the world, understood their own bodies, and accumulated knowledge. It is at this intersection between submerged cities and subtle signs preserved in ancient human anatomy that a deeper question begins to take shape. Has human history been underestimating the level of understanding possessed by its own ancestors? In the year 1862, in France, the paleontologist Louis Lartet discovered a prehistoric human skull at Cro-Magnon, dated to around 28,000 before the Common Era. What stood out was not the shape of the skull itself, but other bones found at the same site that showed clear signs of healing after severe trauma. Clean, deliberate cut marks on jawbones and skulls suggest that Paleolithic humans carried out intentional surgical interventions rather than simply allowing wounds to heal on their own. The clearest evidence comes from the practice of skull drilling, known as trepanation. Hundreds of skulls found across Europe, Africa, and South America display round or square openings, with bone regrowth along the edges, proving that the patients survived the procedure. The earliest examples date to around 7,000 before the Common Era. Performing such a precise operation without causing immediate death would have required a practical understanding of bodily structure, some control over infection, and a basic level of post-operative care. In mainstream historical narratives, medicine is usually said to become systematic in Egypt and Mesopotamia around the 3rd millennium before the Common Era. The Edwin Smith Papyrus, dated to about 1600 before the Common Era, describes traumatic injuries and rational treatments in a way that closely resembles empirical medicine. Yet when this document is placed alongside surgical evidence that is thousands of years older, a difficult question emerges. Did medical knowledge truly appear suddenly, or was it simply written down much later? In South America, Inca skulls from around the 15th century after the Common Era show survival rates after trepanation exceeding 60%, far higher than survival rates for cranial surgery in 19th century Europe. This suggests that indigenous medicine was not based solely on ritual, but on long accumulated practical experience. Yet when Europeans arrived in the Americas, these knowledge systems were often dismissed as superstition and discarded rather than studied with seriousness. The core issue lies in how history evaluates knowledge. When understanding is not presented in familiar written forms or does not align with modern theoretical frameworks, it is easily categorized as accidental or folk practice. But biological traces on human bones cannot be ignored. They are physical evidence that ancient people experimented, failed, and succeeded in understanding their own bodies far earlier than commonly assumed. These discoveries blur the boundary between what is labeled primitive and what is called civilized. They suggest that the ability to observe, learn, and deliberately intervene in nature existed long before city-states or writing systems emerged. When history only recognizes medicine from the moment it is written down, a vast portion of the learning process that preceded it is pushed into shadow. When these fragments are placed side by side, history no longer appears as a clean, linear sequence of progress, but as a flow marked by accumulation and rupture. Practical knowledge of the past, from construction and sky observation to direct intervention in the human body, reveals capacities of learning and memory that go far beyond simple, instinctive survival. Yet knowledge, like people themselves, is not always transmitted smoothly. War, migration, environmental catastrophe, or the collapse of communities can cause crucial skills to disappear, leaving behind only scattered traces for later generations to rediscover. Within the gaps left by history, the question of ancient technology slowly comes into focus. If forms of knowledge once reached a high level of sophistication and were later forgotten, then materials and manufacturing techniques that seem unusual today are no longer isolated anomalies, but signs of developmental phases that time has blurred. From this perspective, ancient metallurgy is no longer just about ores and furnaces. It becomes a test of how we define the technological limits of early societies. Around the year 1903, in what is now Baghdad, Iraq, archaeologists discovered a small object consisting of a clay jar, a copper tube, and an iron core. This object, later known as the Baghdad Battery, is dated to roughly the 2nd century before the Common Era to the 1st century after the Common Era. When reconstructed and filled with a mild acidic solution, such as vinegar or lemon juice, the device produces a weak electrical current. Although its original purpose remains debated, the mere ability of an ancient object to generate electricity challenges the assumption that electrical knowledge began only in the 18th century. Some researchers have suggested that the Baghdad battery may have been used for electroplating, a technique that applies a thin metal coating to another surface. This idea gains weight when artifacts from Mesopotamia display extremely thin, uniform layers of gold that would be difficult to achieve through simple mechanical methods. Yet because no written descriptions survive, mainstream history often treats this as coincidence or overinterpretation rather than as evidence of a once-existing technique. Electrical knowledge is not the only issue. The working of extremely hard stone raises similar questions. In Egypt, stone vessels made from diorite and granite, dated to around the year 2500 before the Common Era, show a level of symmetry and surface smoothness that continues to puzzle modern engineers. Diorite is nearly as hard as steel, yet the Egyptians are believed to have used only copper tools and quartz sand. Tool marks on the vessels suggest steady rotational motion, pointing toward the use of precise, lathe-like tools. And yet no direct archaeological evidence of such machinery has ever been found. The history of technology often explains these objects through exceptional craftsmanship and long periods of labor, but time alone, no matter how abundant, does not produce precision without appropriate tools. Avoiding the question of tooling leaves a critical part of ancient technological history unresolved. Another revealing example comes from ancient Rome. Roman concrete, widely used from the 3rd century before the Common Era onward, has proven more durable than modern concrete in marine environments. Research published in the year 2017 showed that the Roman mixture of volcanic ash and lime forms stable mineral crystals over time, causing structures to grow stronger rather than weaken. This formula was lost after the collapse of the Western Roman Empire in the 5th century after the Common Era, and was only rediscovered through modern chemical analysis. This realization forces us to adjust how we read the past. Rather than viewing history as a straight line of constant progress, it may be more accurate to see it as a fragile network, where knowledge can emerge, spread, and then abruptly break apart. When technical abilities are no longer maintained, what remains are scattered traces, easily mistaken for exceptions or errors. And from these fragments, a broader question begins to emerge. If humans once possessed complex skills and then lost them, can we really assume that development occurred only within isolated islands of civilization? Knowledge, especially technical knowledge, rarely arises in complete isolation. It tends to move, to be shared, and to leave faint connections behind, even after the systems that sustained it have disappeared. Discoveries of unusual materials, distant origins, and unexpected similarities across far-flung regions suggest that beneath civilizations once thought to be independent, quiet currents of exchange were already flowing. From this perspective, archaeology is no longer just about locating where a technology appeared, but about tracing the connections that once linked ancient societies together, connections that modern history has unintentionally cut into isolated fragments. Around the year 2000 before the Common Era, chemical analysis of amber jewelry found at Mycenae in Greece revealed that its source lay in the Baltic region, more than 2,000 kilometers away. This not only confirms the existence of long-distance trade routes, but shows that exchange networks were already operating reliably during the Bronze Age. Amber was not a necessity for survival. Transporting it across such distances points to cultural desire, symbolic meaning, and social status, forces that go far beyond basic subsistence trade. Another line of evidence emerged in Egypt. Mummies dated to around the year 1000 before the Common Era were analyzed in the early 21st century and found to contain traces of nicotine and cocaine, substances derived from plants native to the Americas. While these findings remain controversial and may have been affected by modern contamination, they nevertheless forced researchers to reconsider the possibility of transoceanic contact far earlier than the voyages of Columbus in the year 1492. Not only goods traveled, ideas did as well. Similarities in symbolism, from stepped pyramids in Egypt and Mesoamerica to flood myths found in Mesopotamia, India, and the Americas, are often explained as parallel development. Yet when these symbolic parallels appear alongside material evidence of exchange, the idea of entirely independent origins becomes less convincing. In the Indus Valley, Harappan seals dated to around the year 2600 before the Common Era have been found in Mesopotamia, indicating direct trade between two civilizations separated by thousands of kilometers. These seals were not merely trade items. They carried their own symbolic systems, suggesting mutual recognition between complex societies. This raises questions about the level of geographic knowledge and organizational capacity required to sustain such long trade routes. Mainstream history has often been cautious about proposing early intercontinental contact because doing so requires a reassessment of ancient seafaring skills and social organization. Yet evidence of boats exists from at least the year 8000 before the Common Era, and coastal communities had lived in close relationship with the sea long before that. The assumption that ancient people could not cross oceans is often based more on modern intuition than on direct evidence. These early exchange networks suggest that the ancient world may have been far more interconnected than we once imagined. When goods, ideas, and symbols moved, they carried not only material value, but also knowledge, techniques, and alternative ways of understanding the world. And it is precisely at the moments when these connections broke down that history reveals its fragility. When communication networks collapsed, knowledge sustained through constant exchange quickly lost its context, leaving later societies with scattered memories and the illusion of a fresh beginning. This process did not unfold in abstraction, it left clear marks in specific historical events. Toward the end of the second millennium before the Common Era, a vast, interconnected system around the Eastern Mediterranean began to unravel, sweeping away centers that had long functioned as hubs of trade, diplomacy, and shared knowledge. The near-simultaneous disappearance of major urban centers did not merely bring an end to a political order, it also severed the flow of information that had connected communities for centuries. From this rupture, a new era emerged, one in which later generations were forced to reconstruct history from the gaps left behind by the collapse of ancient networks themselves. History refers to this period as the Late Bronze Age collapse. For many decades, the dominant explanation focused on invasions by the so-called Sea Peoples described in Egyptian records from the reign of Pharaoh Ramesses III around the year 1177 before the Common Era. Yet as modern archaeology has looked more closely, a single cause has proven insufficient. Evidence instead points to a convergence of long-term drought, earthquakes, food shortages, and disrupted trade occurring at the same time, producing a systemic shock that deeply interconnected societies were unable to absorb. Pollen and sediment analyses from regions such as Syria and Cyprus indicate a severe period of aridity beginning around the year 1250, before the Common Era and lasting for several decades. For economies dependent on agriculture and long-distance grain exchange, drought did not merely cause hunger, it crippled the trade routes that kept the entire system functioning. When trade collapsed, cities lost access to essential supplies, triggering social unrest and political instability. Another factor, often underestimated, is the fragility of complex systems themselves. Late Bronze Age kingdoms maintained power through dense networks of treaties, dynastic marriages, and gift exchanges. When a few critical links failed, the entire structure could unravel with startling speed. The disappearance of Linear B writing in Greece after the year 1200, before the Common Era, reveals that not only political authority collapsed, but also administrative and record-keeping systems, causing generations of accumulated managerial knowledge to vanish almost overnight. Notably, after this collapse, the Eastern Mediterranean entered a phase commonly labeled the Dark Age, lasting several centuries. Populations declined, cities shrank, and many technologies were forgotten. Yet calling this period dark reflects more the absence of written records than a complete halt to social life. Smaller communities continued to exist, adapt, and preserve fragments of knowledge, even if no longer on an imperial scale. The Late Bronze Age collapse reveals a crucial pattern. As societies grow more complex and interdependent, they also become more vulnerable to combined shocks. History tends to remember the rise of civilizations, but far less often emphasizes the speed and totality of their collapse. In this case, within just a few generations, a vast interconnected world disintegrated, leaving behind gaps in knowledge that lasted for hundreds of years. This paradox forces us to broaden our understanding of ancient knowledge. When social structures dissolve and collective memory fragments, not all forms of understanding disappear in the same way. Some modes of thought do not depend entirely on institutions or written texts, but are embedded in lived experience, in labor, in spatial awareness, and in the daily measurement of time and environment. And so, even as centers of power and learning vanished, certain abstract patterns of knowledge may have continued to survive, carried forward through practice rather than preserved in words. From dividing land and erecting structures to observing natural cycles and organizing rituals, human beings were compelled to think in numbers, proportions, and shapes, even if they never named them in modern terms. In this context, the earliest traces of mathematics and geometry no longer appear unusual, but instead emerge as a natural consequence of how humans interacted with the world, long before writing existed to record such thinking. Around the year 20,000 before the Common Era, a bone fragment was discovered near the Nile River, now known as the Ishango bone. Its surface bears a series of incisions arranged in deliberate groupings rather than at random. Some researchers have suggested that these markings represent a counting system, possibly even related to prime numbers. While this interpretation remains debated, the intentional organization of the marks indicates that Paleolithic humans were already using numerical structures to track time, resources, or natural cycles. Geometric thinking also appears far earlier than classical mathematical texts. Monumental stone structures such as Stonehenge, built in multiple phases from roughly 3000 to 2000 before the Common Era, demonstrate precise knowledge of distance, angles, and astronomical cycles. Aligning massive stones with the rising sun at the summer solstice required not only long-term observation, but also the ability to measure and reproduce geometric relationships across large open spaces. In Egypt, the pyramids impress not only through their scale, but through the mathematical ratios embedded in their design. The relationship between the perimeter of the base and the height of the Great Pyramid of Khufu closely approximates the value of pi, a mathematical constant formally defined only in the first millennium before the Common Era. While it cannot be claimed that the Egyptians understood pi in its modern abstract sense, the appearance of this ratio suggests that they grasped geometric relationships through practical application and accumulated experience. Histories of mathematics often begin with written sources such as Babylonian clay tablets from around the year 1800 before the Common Era, which contain equations and numerical tables. Yet these texts were likely only the visible peak of a much older practical tradition transmitted through craftsmanship, ritual practice, and architecture. When writing became widespread, knowledge that already existed was formalized and recorded, creating the illusion that it had only just emerged. Another issue lies in how ancient mathematics is judged through a modern lens. When a civilization did not leave behind symbols resembling today's systems, its knowledge is easily labeled as primitive. Yet surveying land, constructing monuments, and tracking time all require a comparable level of abstraction, expressed through images, actions, and spatial relationships rather than symbols on a page. These early mathematical traces reveal that humans developed the ability to abstract the world very early, closely tied to survival and social organization. When civilizations collapsed, practical mathematical knowledge could be lost or simplified, forcing later societies to rediscover and rename concepts that had once been used without formal definition. This realization blurs the boundary between modern knowledge and ancient understanding. Once humans became accustomed to abstracting space and time, extending observation to the slow transformations of the surrounding environment became a natural step. Changes in terrain, sea levels, stone, soil, and natural cycles were not experienced within a single lifetime alone, but accumulated through collective memory, preserved through oral tradition, ritual practice, and lived experience across generations. For this reason, even before it existed as a scientific discipline in the modern sense, sustained attention to the behavior of the Earth emerged very early. This challenges the traditional way the history of science is divided into periods. Rather than viewing geology as a late invention, it may be more accurate to see it as the late systematization of observations humans had been making quietly and continuously for a very long time, as part of their shared existence with a planet that is always in motion. In Anatolia and the Levant, ancient traditions describe great earthquakes, shifting ground, and changes in water sources. When treated as myth, these stories are often dismissed. Yet modern seismic research shows that many of these regions lie along highly active fault zones that have produced earthquakes for tens of thousands of years. Some descriptions preserved in legend align strikingly well with earthquake patterns reconstructed from geological sediments. A clearer example appears in the Mediterranean world. The ancient Greek city of Helike was submerged by an earthquake and tsunami in the year 373 before the Common Era and vanished from the surface for more than 2,000 years. Accounts of Helike were recorded by historians such as Strabo and Pausanias, but for centuries they were considered exaggerations or symbolic tales. Only in the late 20th century did excavations beneath layers of sediment confirm that a real city had been suddenly buried by a natural catastrophe. The case of Helike shows how historical memory and geological reality can intersect. When a major disaster occurs, it leaves not only physical traces, but also deep marks in collective memory. In societies without scientific texts, such memories were passed on through stories, rituals, and warnings. When later generations read these accounts without placing them in a geological context, their practical meaning is easily lost. Another case involves flood traditions. From the Epic of Gilgamesh in Mesopotamia, dated to around the year 2100 before the Common Era, to flood stories found in Chinese and indigenous American cultures, the motif of rising, destructive waters appears with notable frequency. In the 20th century, geological studies in the Black Sea region suggested the possibility of a sudden marine inundation into a former freshwater basin around the year 5600 before the Common Era, dramatically altering the living conditions of coastal communities. While not every flood myth can be traced to a single event, the overlap in timing and description suggests that collective memory can preserve information about large-scale environmental disruptions. Mainstream history often separates natural science from culture. For ancient people, however, observing nature and remembering its cycles was a matter of survival. Communities living near volcanoes, major rivers, or unstable coastlines could not endure if they completely ignored environmental warning signs. Their geological knowledge, though not expressed through equations, was highly empirical in nature. When civilizations collapsed or populations migrated, this knowledge could be lost or stripped from its original context. The stories that remained became myths, and when read through a modern lens, they lost their original function as environmental memory. This has contributed to the mistaken impression that ancient people lacked an understanding of complex natural processes. From this ability to remember and interpret changes in the earth, ancient humans appear to have extended their attention to life itself as it existed under constantly shifting conditions. When the environment was no longer seen as a static backdrop but as an active force, attention to health, illness, and bodily adaptation became inseparable from the experience of survival. These forms of understanding were not divided into separate disciplines as they are today. They existed as an integrated whole where nature, the human body, and ritual were deeply intertwined. Within this intersection, ancient communities accumulated subtle observations about growth cycles, signs of illness, and the relationship between the body and its environment. From this perspective, ancient biology does not appear as a fragmented or purely superstitious field, but as a logical continuation of a worldview that formed very early, a living world in which humans were compelled to understand life itself in order to survive alongside it. In ancient India, Ayurvedic texts dating back to at least around the year 1500 before the Common Era describe the structure of the human body, biological cycles, and the relationship between people, climate, and the seasons in remarkable detail. Although framed in philosophical language and ritual practice, many of their principles are grounded in long-term empirical observation, such as the links between diet, living environment, and disease. When judged by modern medical standards, Ayurveda is often reduced to belief or spirituality. Yet this overlooks the fact that it represents the accumulation of thousands of years of lived experience and survival-based knowledge. In China, traditional medicine began to be systematized by at least the 3rd century before the Common Era, but its core ideas, such as yin and yang and the 5 phases, reflect a holistic biological worldview in which the human body is seen as an extension of the surrounding ecosystem. Descriptions of the pulse, energy cycles, and the body's responses to weather were not arbitrary inventions, but conclusions drawn from clinical observation across many generations. Still, because these systems do not align with Western anatomical models, they have often been dismissed as unscientific. Archaeological evidence also points to deliberate intervention in biological selection. In Mesopotamia, clay tablets dated to around the year 1800 before the Common Era describe techniques for selectively breeding crops, particularly date palms, to improve yield and resilience. This was more than simple farming. It was practical genetics, even without a formal concept of genes as understood today. Another example comes from the Andes. The Inca and pre-Inca cultures used more than 200 plant species for medicinal purposes, including coca leaves to reduce pain and combat fatigue at high altitudes. Such knowledge could not have emerged within just a few generations. It required repeated experimentation, careful memory, and continuous transmission, with failure rates high enough to force learning to become increasingly precise over time. Modern biological history often places the beginning of life science in the early modern period, when microscopes and standardized experimental methods appeared. But this creates a blind spot. Societies without optical instruments were still capable of understanding biology through large-scale observation, long cycles, and cumulative effects. The absence of modern scientific language does not mean the absence of understanding. When civilizations collapsed, biological knowledge tied to specific environments was especially vulnerable to loss. A plant, a remedy, or a farming technique only works within a particular ecological context. When people migrated or ecosystems changed, that knowledge could become ineffective and slowly fade from collective memory. This holistic way of understanding life also seems to have shaped how ancient people imagined their own communities. When humans grew accustomed to observing relationships between the body, the environment, and natural cycles, they applied the same logic to social life, where balance and continuity mattered more than rigid commands imposed from above. In many contexts, social order was maintained not through overt systems of coercion, but through networks of obligation, custom, and shared memory, reinforced through ritual and tradition. Because they operated through these subtle, often invisible principles, early forms of social organization tended to leave behind very little material or written evidence, making them easy to misinterpret as simple or underdeveloped. Yet when placed alongside other ancient knowledge systems, from biology to geology, another possibility begins to emerge. Many communities maintain stability not through centralized power, but through finely tuned social structures built from long experience in how humans live together and in relation to the world around them. In the Indus River Basin, cities such as Mohenjo-Daro and Harappa, which flourished roughly between 2600 and 1900 before the Common Era, present an unusual urban model. There are no grand palaces, no lavish royal tombs, and very little evidence of a clearly defined ruling class. Instead, we find standardized drainage systems, relatively uniform housing, and carefully planned streets. This suggests a form of distributed authority, where order was maintained through shared norms and communal governance, rather than commands issued from an absolute center. A similar pattern appears in Mesoamerica. Before empires like the Aztec rose to power, many early classic Maya cities from roughly the 3rd to the 6th century after the Common Era, functioned through networks of allied city-states, competitive yet never fully unified. Power was reinforced through ritual, astronomy, and calendrical knowledge rather than direct military control. When authority is tied to mastery of time and ritual, social order depends on persuasion and collective agreement, not violence alone. In Polynesia, communities scattered across small islands throughout the Pacific developed social systems based on kinship, tradition, and celestial navigation. By around the year 1000 after the Common Era, they were capable of voyaging across thousands of kilometers of open ocean without compasses or written maps. The authority of leaders came not only from lineage, but from their ability to remember, preserve, and transmit navigational knowledge, a form of power rooted in memory and skill rather than coercion. Mainstream history often favors societies with clear, centralized power structures because they leave behind abundant texts and monumental symbols. Societies organized around consensus, ritual, and customary norms leave fewer physical traces, making them appear simpler than they truly were. Yet their long-term resilience points to a different kind of sophistication, one in which power was dispersed in order to reduce the risk of total collapse. When centralized systems of authority fail, as during the Late Bronze Age collapse, societies can descend into profound chaos. In contrast, more decentralized models often adapt more effectively to environmental change and crisis. However, this same lack of concentration makes knowledge harder to formalize and preserve over long periods, especially when faced with invasion or rapid cultural transformation. These early forms of social organization show that power does not always rest on violence or strict control. It can be grounded in knowledge, ritual, and the ability to regulate relationships between people and between humans and nature. When history remembers only the most visible expressions of power, many alternative models are pushed to the margins, even though they once functioned effectively under harsh and unstable conditions. When power is understood as a network rather than a center, maintaining social order no longer depends on the constant presence of visible force. In many ancient communities, behavior was shaped not by immediate commands, but by patterns repeated in everyday life, gradually embedded in how people thought and acted. Norms and rules did not need to exist apart from spiritual or cultural life. They were woven directly into the rhythm of daily existence, reinforced through ritual, storytelling, and collective memory. It was precisely this mechanism of maintenance through consensus that allowed such societies to remain stable over long periods, even while leaving very little clear evidence behind. From this perspective, ancient law does not appear as a crude forerunner of modern legal systems, but as a set of refined structures designed to function in conditions where social cohesion mattered more than overt enforcement. The Code of Hammurabi, carved around the year 1754 before the Common Era in Babylon, is often presented as one of the earliest legal texts. What is less emphasized is that it did not create law from nothing. Instead, it formalized norms that had long existed within Mesopotamian society. Inscribing the law in stone was not merely about punishment, but about fixing moral values at a time when society was becoming more complex and increasingly fragile. When laws need to be written down, it is often a sign that traditional order, once sustained by memory and custom, is coming under strain. In ancient Egypt, the concept of Ma'at, present from at least the 3rd millennium before the Common Era, represented cosmic order, justice, and balance. Ma'at was not a legal code, but an overarching moral principle that guided individual behavior and legitimized the authority of the pharaoh. Upholding Ma'at was a shared responsibility from ruler to commoner. When social order is tied to cosmic order, law does not require constant enforcement, because violation carries the meaning of disrupting a sacred balance. In non-literate societies, law existed as custom. In many indigenous communities across Africa and the Americas, rules governing land, marriage, and exchange were transmitted through ritual and storytelling. Those who violated them faced not only material penalties, but exclusion from the community, a powerful form of social control in small groups. Yet because these systems left no written records, history has often treated them as vague or underdeveloped. A common feature of early legal systems is their deep connection to specific environments and social structures. The laws of river-based societies differed from those of nomadic groups or island communities. When societies expanded, interacted, or collapsed, these legal systems were difficult to transfer intact. They were either replaced by new frameworks or reduced to custom, stripped of their original meaning. Modern history, with its focus on formal legal texts, often overlooks the long period during which law existed primarily through memory and practice. This creates the impression that social order only emerged with the rise of the state and writing. In reality, many communities maintained stable order for centuries without centralized legal institutions. It is at this point that power begins to take on a more subtle form, not rooted in direct coercion, but in the ability to shape memory and control the flow of knowledge. When social order depends on what people collectively believe and remember, access to knowledge becomes a decisive factor in determining each person's place within the community. Those who hold the authority to interpret tradition, ritual, or specialized knowledge do more than preserve understanding. They shape how society understands itself, quietly guiding behavior, identity, and continuity across generations. For this reason, knowledge did not circulate freely. It moved along selective pathways where learning was always tied to responsibility, obligation, and sometimes exclusion. From this perspective, history is not only the story of what was known, but also of what was restricted, kept hidden, or allowed to exist only within small circles, before disappearing alongside the social structures that once sustained it. In ancient Egypt, from around the 3rd millennium before the Common Era, priests were not only responsible for ritual, but also held knowledge of astronomy, medicine, mathematics, and architecture. Access to this knowledge required long training and approval within the religious system. What was taught publicly was often symbolic, while deeper methods and principles were kept internal. When temples were destroyed or religious authority declined, much of the knowledge bound to them vanished without ever being widely copied. A similar pattern appears in Mesopotamia. Scribal schools, active from around the year 3000 before the Common Era, trained a small elite capable of reading, writing, and calculation. Clay tablets reveal a strict curriculum, but also show how knowledge was confined to a narrow class. When cities were destroyed by war or economic collapse, this class dissolved, interrupting the transmission of administrative and scientific knowledge. In ancient Greece, knowledge began to be discussed more openly from the 5th century before the Common Era onward. Even so, many philosophical schools functioned as closed communities. Pythagoras and his followers, for example, combined mathematics, music, and philosophy within a system that carried a mystical dimension, with much of its knowledge reserved for initiates. When these communities disintegrated, what remained in written form were fragments, making it difficult for later generations to reconstruct the original system of thought. The control of knowledge was not only about protecting power, it also reflected a fear of imbalance. In many ancient societies, knowledge was seen as a force capable of causing disorder if misused. Limiting access was therefore a way to preserve stability. Yet this same restriction made knowledge fragile. When those who held it died or were removed, understanding that had never spread widely could disappear with them. History often celebrates moments of enlightenment when knowledge becomes accessible to broader populations, but these moments usually follow periods of profound loss when earlier bodies of knowledge have already been fragmented. Reconstruction is built from what survives, not from the full scope of what once existed. This creates the illusion of steady progress, when in reality, knowledge advances through alternating cycles of accumulation and erasure. Because knowledge is so closely bound to power and collective memory, its disappearance is rarely a simple historical accident. When closed systems of transmission collapse, the deepest layers of understanding often have no chance to spread into the wider community and preserve themselves. And beyond this natural fragility, there exists another force, colder, deliberate, and selective in nature. In moments of transition, when a new order seeks to assert its legitimacy, an incompatible past is often treated as an obstacle. The removal of symbols, texts, or memories is no longer merely a byproduct of chaos, but becomes a deliberate tool for reshaping collective perception. From this point on, history is not only hollowed out by time, but actively bent by conscious decisions about what should be remembered and what must be forgotten. One of the clearest symbols of this loss is the Library of Alexandria. Founded around the 3rd century before the Common Era under Ptolemy I, the library was not simply a repository of books, but a research center that gathered scholars from across the Hellenistic world. Ancient estimates suggest it once held hundreds of thousands of papyrus scrolls, including copies of texts from Egypt, Mesopotamia, India, and Greece. Its destruction did not occur in a single moment, but through multiple episodes. From the time of Julius Caesar in the year 48 before the Common Era to later religious conflicts in the centuries that followed. What matters is not the exact number of scrolls lost, but the kinds of knowledge that vanished. Mathematical, astronomical, medical, and geographical texts may have existed in forms that later generations would never encounter. When such works were burned or decayed without being copied, entire chains of knowledge were severed. History then had to rebuild from scattered remnants, creating the impression that knowledge progressed steadily from simple to advanced, when in reality it may have been a partial recovery of what had already been lost. A similar pattern appears in episodes of conquest and conversion. When the Spanish Empire invaded Central America in the 16th century after the Common Era, vast numbers of Maya and Aztec books written in hieroglyphic scripts were burned as heretical. Only a handful of Maya codices survive today. As a result, much of their knowledge of history, astronomy, and ritual was erased permanently. What remains has been reconstructed from stone inscriptions and European accounts, each carrying its own biases and limitations. In China, the burning of books and burial of scholars under Qin Shi Huang in the year 213 before the Common Era is often cited as an act of tyranny. Yet it also reflects a recurring pattern. When a new order seeks to consolidate power, controlling the past becomes a priority. By erasing older frameworks of understanding, new authority creates a historical narrative that supports its own legitimacy. Mainstream history often presents such events as brutal exceptions, but when viewed more broadly, the destruction of knowledge appears again and again across civilizations. Texts that conflict with a new ideology or threaten existing power structures tend to be removed. As a result, history becomes a curated record, shaped not only by the passage of time, but by deliberate selection. It is this loss of interpretive continuity that creates another layer of silence in history, not silence because traces no longer exist, but because the traces have become unreadable. When knowledge is separated from the context that gave it meaning, what remains is easily misunderstood as anomaly, vague symbolism, or coincidence. Over time, successive generations impose new interpretive frameworks upon these remnants, unintentionally obscuring their original function and purpose. For this reason, loss does not arise only from acts of destruction, but also from breaks in language, symbolism, and collective memory. At this point, history does not lack evidence. It lacks the keys to interpret it. And it is within this distance that the more subtle mysteries of ancient knowledge continue to exist, not because they have vanished, but because they are still waiting to be understood on their own terms in a world that has largely forgotten how to ask questions the way their creators once did. On Easter Island, the stone statues known as moai were carved primarily between around the years 1250 and 1500 after the Common Era. For centuries, they were viewed simply as ancestor figures, expressions of a so-called primitive belief system. Yet more recent research suggests that the moai were positioned along pathways and near sources of fresh water, implying that they may have functioned as markers for orientation and resource management in an environment of extreme scarcity. When the island's ecosystem collapsed, the practical meaning of this system was lost, and the statues became detached from their original context, transformed into isolated enigmas. A similar case appears on the Nazca Plateau in Peru. The Nazca lines, created between roughly the year 500 before the Common Era and the year 500 after the Common Era, stretch across dozens of kilometers and are fully visible only from above. In the 20th century, they were commonly interpreted as astronomical calendars or religious rituals. Yet hydrological studies show that many of the lines align with underground water sources and the Puquio's water management system. If this interpretation is correct, the Nazca lines were not purely symbolic, but practical maps created by a society forced to survive in an exceptionally arid environment. The issue here is not choosing a single explanation, but recognizing that when ecological and social contexts disappear, surviving structures are easily stripped of their original function. History, lacking data about environment and everyday practice, often fills these gaps with symbolism and ritual because those are the most familiar interpretive languages. But this substitution can obscure layers of practical knowledge that once existed. Another example comes from the megalithic monuments of Europe. Many stone circles and burial structures built from the 4th millennium before the Common Era are typically associated with belief systems or astronomy. However, some researchers suggest they also marked territories, migration routes, or cycles of land use. When societies shifted away from small communal structures, these markers lost their regulatory function and remained only as mysterious monuments for later generations. Modern history tends to classify sharply either science or religion. But for ancient people, a single structure could simultaneously function as a map, a calendar, a ritual site, and a tool of social organization. When we force such creations into a single category, we inadvertently erase other layers of meaning. This is not a failure of ancient understanding, but a limitation in how later societies read the past. From this prolonged silence, history reveals another of its limits. It favors what can endure physically over time and overlooks what existed primarily in lived moments. When social contexts dissolve, not only do the meanings of stone and symbol fade, but entire forms of non-material knowledge slip beyond the reach of later observers. Ways of understanding the world transmitted through voice, rhythm, gesture, or seasonal repetition leave few recognizable traces. Yet they once played a central role in organizing human life. For this reason, beneath monuments that have been misunderstood lies an even deeper loss, the disappearance of lived experiences that once shaped how people felt time, space, and their own sense of self. At this level, history does not lack artifacts to excavate. It lacks the means to listen to what only existed while people were still living within those rhythms. Music is a clear example. The oldest known musical instruments, such as the bone flutes found in the Holyfels cave in Germany, dated to around 40,000 before the Common Era, show that humans developed systems of pitch and rhythm remarkably early. Music was never just entertainment. In many traditional societies, it functioned as a tool for memory, for regulating collective emotion, and for transmitting knowledge. In the absence of writing, melody and rhythm made it possible to remember long sequences of information, from seasonal calendars to myths and laws. Yet music almost entirely disappears from the archaeological record. We find instruments, but not the melodies themselves. When communities collapsed, their music vanished with them, leaving almost no trace. Because history depends so heavily on physical remains, it easily overlooks the central role of sound in organizing ancient societies. This creates the false impression that ancient thought relied mainly on images and material objects, when in reality it may have been far more balanced. Another form of light knowledge was spatial orientation and memory. Before written maps, many communities used songs, narrative sequences, or rituals to memorize vast landscapes. In Australia, Aboriginal songlines, documented from the 19th century onward, describe transcontinental routes through song. Each segment of melody corresponds to a specific feature of the land. When sung in the correct order, the song allows a person to travel hundreds of kilometers without a map. These systems were not unique to Australia. Anthropologists suggest that many nomadic societies in Africa and Central Asia also relied on similar methods, combining sound, story, and ritual. But because these practices leave little physical evidence, modern history rarely recognizes them as genuine forms of geographic knowledge. Human understanding of time was once experienced differently as well. Before written calendars, biological rhythms, astronomical cycles, and collective rituals helped people locate themselves within time. When these systems were disrupted by invasion or rapid cultural change, people lost the ability to read time in the old way. What remains are stone structures or isolated symbols, difficult to interpret without the accompanying sound, ritual, and shared experience that once gave them meaning. By focusing only on what is heavy and durable, history has overlooked half of the ancient world's knowledge, the part rooted in direct lived experience. This does not just impoverish our picture of the past, it makes many civilizations appear less sophisticated than they truly were. When knowledge is not carved into stone, it is often treated as if it never existed. Recognizing this absence forces us to shift our perspective when approaching the past. When knowledge is understood not as the property of individuals, but as a flow sustained by the community, non-material forms of understanding become easier to see within the logic of ancient societies. Sound, memory, and lived practice did more than transmit information. They created a sense of belonging, where each person functioned as one link in a shared awareness larger than the self. It was precisely through this deep integration that knowledge could exist beyond the lifespan of any single individual, continually recreated through ritual, rhythm, and everyday ways of living. From this perspective, the idea of collective consciousness is no longer abstract. It becomes a key to understanding how many ancient societies were able to maintain continuity and long-term stability, even though most of what they knew and lived by was never carved into stone or written down. In early tribal and village societies, reputation and memory did not belong to individuals, but to lineages and to the community as a whole. Buildings bear no names of their builders. Songs have no recorded authors. Knowledge was understood as shared property, not as personal achievement. This helps explain why archaeology rarely uncovers traces of ancient inventors, even when innovations clearly required high levels of creativity and intelligence. When history searches for individuals, it often finds none, and mistakenly concludes that innovation did not exist. A clear example can be seen in megalithic constructions across the world, from Stonehenge in Britain to the dolmens of Korea, built roughly between the 4th and 2nd millennia before the Common Era. There is no evidence of celebrated architects or commanding figures. Construction appears to have been a collective act, embedded in ritual and social cycles. When collective consciousness is central, a structure does not need an individual signature to carry meaning. In many ancient cultures, collective memory was sustained through recurring ritual. The retelling of ancestral stories, catastrophes, or migration journeys was not only about remembering the past, but about synchronizing the shared awareness of the community. When rituals were disrupted through invasion, forced conversion, or displacement, collective memory quickly fragmented. Later, societies were left with scattered remnants, easily misunderstood or transformed into myth. Mainstream history often privileges societies that left behind personal texts, diaries, or biographies, but this unintentionally obscures societies that operated according to a different logic. When a civilization leaves no individual voices, it is often judged as having no history in the modern sense, even though it may have possessed an extraordinarily complex system of collective memory. One important consequence of underestimating collective consciousness is a misunderstanding of motivation itself. When individuals are not placed at the center, social decisions may prioritize long-term balance over short-term gain. This helps explain why some communities maintain sustainable relationships with their environments for thousands of years, until their social structures were disrupted or destroyed. Changes in social organization therefore bring about deeper shifts at the level of perception, as emphasis gradually moves away from the community toward the individual and new power institutions. Not only is collective memory reorganized, but the very sense of time is rewritten. Societies that once operated through the repetition of ritual, seasonal cycles, and shared memory did not require a linear timeline to define the meaning of their existence. Only when a new order demands inheritance, progress, and continuous control does time begin to straighten into a sequence of connected milestones. From that moment on, the shift is not merely a change in how years are measured, but a fundamental transformation in how humans relate to the past and imagine the future, marking a subtle boundary between ancient worldviews and modern ways of thinking. The cyclical concept of time appears clearly in the Maya calendar, used from at least the 3rd century before the Common Era. Their long count system was not designed to predict an end of the world, but to situate events within vast cycles spanning thousands of years. When a cycle ended, it did not signify destruction, but rebalancing. Yet when the Maya calendar is approached through a modern linear mindset, this meaning is distorted and transformed into apocalyptic narratives detached from their original context. In ancient India, the concept of the yugas, described in texts with origins in the 1st millennium before the Common Era, presents world history as a sequence of repeating ages marked by the rise and decline of moral order. This was not an attempt to predict specific events with precision, but a cognitive framework for understanding social change across immense spans of time. When history is read as a story of uninterrupted progress, these cyclical models are dismissed as myth, even though they may reflect long-term observations of environmental and societal fluctuation. In China, the idea of the mandate of heaven emerging during the Zhou dynasty around the 11th century before the Common Era also ties history to moral cycles. A dynasty rises when it maintains order and falls when it loses it. History, in this view, is not linear advancement, but continual correction. When ancient chronicles are read through a modern lens, this ethical cycle is often reduced to political superstition. The shift toward linear time thinking became more pronounced in Europe during the late Middle Ages and the Renaissance, when history began to be told as a continuous narrative of human progress. This perspective generated powerful momentum for development, but it also weakened the ability to recognize recurring cycles of crisis, collapse, and restructuring. When a society believes it is always moving upward, warning signs from the past are easily ignored. Mainstream history, built on a linear timeline, tends to treat civilizational collapses as isolated failures. But when viewed through a cyclical lens, these collapses may represent transitional phases in which knowledge and social structures are reorganized. Ignoring cyclical conceptions makes it difficult for modern history to integrate evidence of repeated large-scale crises. When ancient societies understood time as circular, their knowledge focused on maintaining balance rather than conquering the future. This directly shaped how they built, farmed, and organized social life. When linear thinking replaced this view, priorities shifted toward growth, expansion, and accumulation, sometimes at the expense of ecological limits. Because time is not perceived in the same way across all societies, history is never recorded in a completely neutral manner. When one sense of time becomes dominant, especially linear time tied to progress and inheritance, it also establishes the criteria for what is considered important. Forms of knowledge, experience, and ways of living that cannot be easily placed into a clear before and after sequence gradually fade from view, not because they never existed, but because they do not fit the prevailing narrative. From this point on, history begins to operate as a quiet process of selection, where memory is preserved not only based on its impact, but also on its ability to fit into a shared narrative of power and progress. The result is a picture of the past that appears complete, yet in reality has filtered out many layers of understanding that once shaped how people perceived the world and themselves. In many ancient civilizations, the everyday lives of the vast majority were never recorded. Farmers, craftsmen, herders, and women rarely appear in chronicles. This is not because they were unimportant, but because history was written by those with power and access to writing. When surviving sources mainly reflect elite perspectives, the image of the past becomes distorted, leaving many social structures and forms of practical knowledge hidden from view. A clear example can be found in ancient Rome. Historical texts focus on emperors, wars, and political reforms, yet archaeological studies of housing, household goods, and diet reveal that the daily lives of ordinary people were crucial to the empire's long-term stability. When food supply networks broke down in the 3rd century after the Common Era, Rome's weakening was not only a political problem, but a crisis of everyday life. These dimensions, however, were reconstructed only much later when material evidence began to receive attention alongside written sources. Another form of loss concerns women's knowledge. In many ancient societies, women held expertise in childbirth, healthcare, herbal medicine, and child-rearing. But because these domains were rarely recorded in official texts, their knowledge was often dismissed as folk practice and excluded from the history of science. As social structures shifted and power became more centralized, many of women's roles were reduced, and with them, entire systems of knowledge quietly faded. Mainstream history also tends to prioritize major centers of power while overlooking peripheral regions. Yet many important innovations emerged at the edges of systems where communities were forced to adapt creatively to harsh conditions. When these regions left behind fewer written records, their contributions were easily absorbed into the broader narratives of dominant empires. This process of selection is not always deliberate. It reflects the limits of surviving sources and research methods. But when these limits go unrecognized, history is received as a complete record rather than an incomplete slice. This creates the illusion that the past was simpler than the present, when it may in fact have been far more complex and diverse. From the fragmented remnants that remain, history gradually reveals the limits of its own framework. When traces can no longer be connected into a meaningful whole and exist only as isolated details, our approach to the past narrows as well. For a long time, understanding history meant searching for clear evidence and fitting it into familiar explanatory models, often at the cost of everything that did not easily fit. But as more scientific disciplines reveal layers of human experience that do not easily fossilize into objects or written records, that assumption gradually loses its persuasive power. From this point on, the mystery no longer lies in a lack of data, but in the limits of our own methods of approach. The past is not only larger than what was recorded, it is larger than what we have historically allowed ourselves to question. One fundamental issue is the very concept of evidence. Modern history prioritizes what can be measured, quantified, and preserved over long periods of time. Stone, metal, and writing are therefore treated as more reliable than memory, ritual, and lived practice. Yet this preference reflects the capabilities of research methods more than the true importance of these elements in ancient human life. When what endures physically is treated as central, history quietly equates material durability with intellectual depth. In the 21st century, new scientific fields have begun to challenge this view. Landscape archaeology shows that many ancient societies shaped their environments on large scales without leaving monumental architecture behind. Ancient DNA analysis reveals waves of migration, interaction, and population replacement never mentioned in written sources. Paleoclimate research helps explain the rise and collapse of societies once attributed to moral decay or invasion alone. These methods do not rewrite history from scratch, but they widen the frame, allowing us to see what once lay beyond our field of vision. This leads to a subtle but important shift. History is no longer a fixed narrative of certainty, but a working hypothesis in constant revision. Ancient mysteries in this context are not failures of knowledge, but signals of an expanding understanding. When a new discovery forces us to revisit old questions, it does not weaken history. It makes it more honest about the complexity of the past. This shift, however, is not without resistance. Stable historical models provide comfort. They help people locate themselves within an orderly story. Acknowledging that the past is more complex, layered, and uncertain can be unsettling. Yet that discomfort is precisely the sign that history is being approached as a living field, rather than a closed collection of conclusions. When all these layers finally settle, the story does not end with a definitive answer, but with a quiet change in perspective. When ancient mysteries are placed side by side, they do not form a complete system. Instead, they reveal the spaces between historical layers, places where knowledge once existed, then faded from view through time, upheaval, and the selective workings of collective memory. What remains in the end is not a sense of absence, but a quiet awakening to the limits of familiar stories. In that light, history appears as a fragmented current, where humanity has not only learned how to move forward, but also how to listen for the fragile traces of what was once known, once lived, and is still waiting to be recognized through a more open way of asking questions. The greatest mysteries of the past do not necessarily lie in monumental structures or dazzling artifacts. They exist in the silences between timelines, where knowledge once lived but left behind too few traces to defend itself against modern interpretation. When a society collapses, what disappears first is rarely stone or metal, but ways of understanding, organizing, and experiencing the world. Only after these vanish do physical remains become mute and difficult to explain. Mainstream history, driven by the need to organize and teach, is forced to simplify. But simplicity should not be mistaken for completeness. Every linear model, every neat evolutionary framework is the result of selection. What does not fit is often pushed aside, not because it is false, but because it complicates the story. And it is precisely within that complexity that many answers may have existed, answers that were never asked in the right way. When we look back at these 30 ancient mysteries as signs of loss rather than of the supernatural, we begin to understand that history does not deliberately hide anything. It simply reflects the limits of collective memory, of research methods, and of what is allowed to survive through time. Civilizations that once held deep understanding of nature, society, and the human condition may have disappeared not because they were poorly adapted, but because the world changed faster than their ability to preserve knowledge. This realization does not lead to pessimism, but to a form of intellectual humility. By accepting that the past may have been richer than what remains, we also accept that the present is not the final peak of understanding. Knowledge today, if not transmitted, protected, and embedded in lived context, may become the mystery of tomorrow. At this closing point, there is no single answer to all mysteries, and none is required. The greatest value of revisiting what history has not fully told lies not in replacing one narrative with another, but in expanding our capacity to ask better questions. When we accept that history is an ongoing process, ancient mysteries cease to challenge knowledge itself and instead remind us of the fragility of human memory. It is within that fragility that the past continues to whisper, not to be worshipped or idealized, but to be listened to, slowly, carefully, and without imposition. When that happens, history is no longer something dead, but becomes a space of dialogue, where past and present coexist, question one another, and remind us that understanding has never been a finished process. From here on, our approach to history must become more cautious and more humble. When what remains are only fragments of once continuous chains of knowledge, rushing to label them as unexplainable often says more about the limits of the present than about the capacities of the past. Isolated traces, separated from the context that once gave them meaning, are easily mistaken for anomalies, when in fact they may be the surviving fragments of systems that once functioned as complete wholes. For this reason, what matters most is not closing ancient mysteries with a final conclusion, but widening our perspective enough to accept that history always contains layers of meaning that exceed the ability of any single era to fully explain. Mainstream history offers us order, timelines, and a sense of certainty. Yet that very sense of certainty can make us forget that human knowledge does not develop in a straight line. It accumulates, breaks apart, and is sometimes rediscovered in entirely different contexts. Civilizations that once possessed deep understanding of astronomy, biology, society, or the environment may have vanished not because they were less advanced, but because the world around them changed faster than their ability to preserve and transmit collective memory. When we look back at the 30 ancient mysteries as signs of broken knowledge rather than isolated supernatural phenomena, history begins to feel closer and more human. It is no longer a story of primitive people slowly climbing upward, but a story of societies that once understood a great deal and were then forced to begin again from what remained. And this does not belong only to the distant past, it holds up a mirror to our own time. Modern knowledge, if not taught, protected, and rooted in human context, can also become the mystery of the future. What feels obvious today may become difficult to understand just a few centuries from now if the chains of connection are broken. History, then, is not only a record of what has passed, but a quiet reminder of the responsibility the present holds toward generations yet to come. Thank you for spending this time with Bedtime History. As the night grows quieter and thought begins to slow, questions about the past may no longer feel unsettling, but instead become gentle companions. In what follows, we will continue to explore the stories history never fully told, not to arrive at a final answer, but simply to keep listening.